this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to dwell into the topic traveling salesman problem using an activity based approach. So let's see what is traveling salesman problem. So the traveling salesman problem TSP will be here it will be given n set of cities and distances between every pair of cities. The problem is to find the shortest possible route that visits every city exactly once and returns to the starting point. Note there is a difference between the traveling salesman problem and the Hamiltonian circuit problem. In the Hamiltonian cycle problem, it is to find if there exists a tour that visits every city exactly once. Here we know that the Hamiltonian tour exists because the graph is complete, and in fact many such tours exist. The problem is to find the the minimum weight in a Hamiltonian cycle. So but the goal of the TSP problem is to find the most economical way to do of a select number of cities with the following restrictions. You must visit each city only once and only once. You must return to the original starting point. So this is the basic difference between the Hamiltonian cycle and the TSP problem. So there are different approaches in solving the traveling salesman problem. So it will be simple or naive approach, dynamic programming approach, greedy approach. In any ways you can follow and you can solve the traveling salesman problem. So if we consider the naive approach, first we will consider city 1 as the starting point and the ending point. The route will be cyclic. Any point can be considered as the starting point. At the second step, we will generate all the possible permutations of the cities, which are n-1 permutation. After that, we will find the cost of each permutation and keep a record distance of the minimum cost again. At last, we will return with the minimum cost. So this is the simple naive approach. So TSP belongs to a class of class of problems in computational complexity analysis called the NP complete problem. If you could find a way to solve an NP complete problem quickly, then you can use the algorithm to solve NP problems quickly. So the time required to solve the problem using any currently known algorithm increases very quickly as the size of the problem grows. Common NP computational problems are Boolean satisfiability problem, N-puzzle, knapsack, Hamiltonian, traveling salesman, subgraph isomorphism problem. So let's see this traveling salesman problem as an activity by the second year AIDS students.
Hello everyone, myself Suman.
I'm Shankar. I'm Amsi Vishnu. I'm Mohammed Aslam. I'm Wilfred Roy.
Now we are going to present a real-time example of traveling salesman problem.
Here, Suman acts as the source S. Shashank acts as source A. Next to Shashank, Vamsi acts as source B. Next to that, Haslam acts as source C. And Wilfred as source D and final source. And here are the four sources of the traveling salesman. At the first step, the source S travel to the node A and then travel to node A. Next step, he travels to node C, which is the nearest node and the best pathway. And next to C, he travels to D. And next to D, he travels to node C. and the last and final notes of the traveling salesman. And the source again came to the starting point. After that, the four notes have been reached and they return to the